Okay, friends, I have here a standard prophylactic kit, extra small. I'm not afraid to admit it. Okay, we're gonna. I have no idea what's gonna happen. What the fuck, man?
That's heaps sick, eh?
Evening all, and welcome back to the Busted Junk channel. Tonight we have an especially busted piece of junk. This is a Chinese hydrogen generator. Now, this isn't the first time I've had to put tools onto it, because there's a reason they're cheap, as we'll soon see. It's functionally a pretty simple device. You may have heard of HHO generators. So basically electrolytic devices that split water into hydrogen and oxygen. Well, that's what this thing does. It just manages to separate the oxygen and only passes out the hydrogen. The next question is, well, why do you want this? Why would you need this? Well, we use this as a hydrogen source for a flame ionization detector in a scientific instrument. This is on the low end of cost. You probably pick one of these up for about 1,000 Australian dollars. The professional ones, which don't require the same level of intervention as we were about to engage in here, they kind of start at about $14,000. So there is a reason that we choose to buy these. Let's have a look quickly at the diagram. I'll show you what's going on in here. So we have a water tank up the back. We have to have some kind of source for our hydrogen. And this happens to be water. H2O being water. So we basically drain water from the bottom of the tank into the electrolytic cell here. And I'm really not going to do it justice, but these things, what they are essentially is a whole bunch of metal plates stacked together, and in between which is an electrolytically permeable membrane. It's a fancy word for saying a piece of electrically conductive plastic. Maybe I'm not doing that justice, but anyway, that's what it is. I can open this one up. I have previously opened this one up and show you what goes on in there. But it's basically passing a current through the water in a very short space, and it electrolytically splits the atom there, and you get the output of water, which returns back into the water tank. You also get the oxygen output back into the tank through certain sections of the stack, because there's a whole bunch of plates in here. And then you also get the hydrogen output. Now, from that little hydrogen output, it's the little swaged plastic fitting up the back there. It goes into a water separator, which basically just means if there's any water that ends up in there and enough of it accumulates, it gets right up to the top, and it's got a little electric switch which will activate, and it'll turn the machine off and probably throw an error code. I've never seen any water ever into that. We then go off and branch off into the analog pressure gauge at the front. And then we have another tube which runs down into a four-way T, which goes into a digital pressure. I believe this is probably the best way to describe it, a digital pressure gauge, because these machines run on a constant current power supply. This is something I did a bit of a deep dive into yesterday. Not something I fully understand, probably not something I'm going to be able to do much justice to, but instead of being at a fixed voltage, it adjusts the current, so that the voltage does change on these. Regularly it will see about 2 volts, 2.5 volts is what a healthy one of these should be operating at. That's how I know that this thing was so badly out of shape, because it was trying to pump 5 volts through it. It doesn't sound like a lot, but I believe the current is pretty high, so this thing is what controls that current. Then it has an emergency pressure relief valve also on that circuit, which will basically just cut the current if it senses it's gone too high. Then finally it will branch out into a desiccant column, which is this funny coloured looking thing here, and to a needle valve at the back, and to a swaged output here. And one of the funny things, like I work with these kinds of machines regularly, like professionally built machines. And as is the case with so much of this Chinese stuff, like, yeah, they have little glimmers of hope here where you have properly swaged fittings with, you know, proper swage fittings, metal on metal. And then you see stuff like this where you've got stainless steel going into a piece of plastic. No, it doesn't operate at extremely high pressures, but I have already had one of these blow out. At the top of the, you'll notice that this fitting here is slightly shorter. Well, that's because it blew stripped the threads off and blew this fitting straight off, because of course the plastic's the weak point. Of course that's what's going to be what will let go when the pressure gets too high. So to solve that, I had to cut the thread off and basically re-threaded it down a little bit lower. The reason I have this here now, this has actually just been sitting next to my coffee table for months now, is because I believe that the electrolytic cell has died in it in a way that I can't repair it. Now, I've tried to acid wash the metal plates in there. I thought this would be an easy job. I would just pull it apart, acid wash, and then put it back together. Well, it turns out, no, that's not the problem. They did suggest to take a very large resistor. I think it was 100 ohm, 10 watt resistor. This thing is a chonker. And put it in line to basically simulate the electrolytic cell and measure the voltage across the poles. And although I kind of got a reading which would suggest that this thing is dead, I don't think I was 100% happy with it. I went ahead and bought this anyway because it was fairly cheap and it wasn't my money. So we'll see what happens, I guess. So a couple of things are just jumping out at me. This one here, I'm really not a fan of. So what they've done is taken 1/8 inch, probably Teflon, possibly some other kind of plastic line, and instead of using like a rigid line like you would normally expect in a situation like this, they've taken a piece of metal tubing, which looks like it could be a 1/16th, but it could also be some strange size, and they pushed it inside of the plastic tubing. I'd say they've probably done it with a bit of heat and a bit of force, and it just doesn't really feel right. So the way that it would sit in there has caused a little bend, a little kink in the pipe, and given that after this point it's now at pressure, which can reach, I believe, up to about 100 and, is it 60 psi it normally runs at? I can't remember, but still, 60 psi isn't a small number of psis. So I think I might go to replace this, so that'll rule out finishing it tonight. I might just see what I can track down tomorrow and see if I can actually swage in some proper steel line, which that actually goes up to another fitting, which is in exactly the same format, just here, and you can feel it's kinked. Like it's too short. It is too short. It should be pulled right down like this, and you can see when you do put that pull into it, it bends it, kinks it. Not a huge fan of it. And the other thing that jumps out at me is this. What's that discoloration from? So this is the oxygen return line. So you get water in at the bottom, and then you should end up with a bit of oxygen and maybe a little bit of water out of the top. And this passes to the water tank here, and you just get the oxygen that vents through a little hole in the lid here. I don't know where that burniness has come from, but I'm not a huge fan of that either. So that's going to get replaced. Yeah, interesting. So I'm just having a bit of a hunt around in my bits pile at work. That is the 10mm cap from the original H2 cell. But that swage fitting there is standard swage lock 1/8, and this is PTFE Teflon high pressure tubing, which I feel is a much better choice in a situation like that. Now, does a swage lock, a standard swage lock cap, fit on these? No, it does not. It's a different threading. But the ferrules very closely match the geometry of the inside of that swaged receiving fitting there. Would it work? Yeah, it probably would. But I think what I might do is go for a professional level PTFE ferrule set. This is a stainless set. Remembering that what we pulled out of it was essentially a piece of moulded bloody rubber, which I wouldn't trust at all. So I think what I might do is just tool up to with this tubing, with this cap, with the original caps, and then just change over the ferrules to something a little bit more appropriate. So I'll show you what they look like now. Alright, so a bit of digging needed, but this is what I was talking about. So it's a 1/8 PTFE ferrule. Same thing as the steel ones, but these will conform perfectly in there, and they're a little bit better than those. It seriously does just feel like jelly, whatever they supplied me with. I'll show you that later. Alright, so I've hooked up the swaged 1/8 line into the back of the H2 generator here. H2 electrolytic cell, I should say, and it hooks up underneath and into the water separator up there. And I've hooked up the water inlet and water return line, rinsed out the water tank because it's been sitting there for far too long. And now I'm just reinstalling the cell, and these things are electrically isolated, so they come with these weird little electrically isolating panels, I suppose. And it's absolutely important that they be reinstalled with it, and that they sit on these little electrically isolated pads in the bottom. And then we'll go through and reconnect the positive and the negative terminals, which I've marked. And we'll see if it works. Fill it up with water and see what happens. Alright, so this is a hydrogen leak detector that I'm just calibrating. We're about to plug it in. Nothing's leaking. Got the multimeter handy. So let's plug it in and see what happens. Who knows what's going to happen. Holy shit. So we do have some return oxygen. Now let's test the voltage across the electrolytic cell. So it's going to read 150 until it builds pressure. Now the needle valve at the back is closed, so if it's not leaking, it should build pressure. Now I want to see around about anywhere between 2 and 5, but I think 2 is probably best, but let's see what we see. We've got 2.3 volts on the cell, which is absolutely minty fresh. That's good. So in a moment, after it's settled down, we should see the output flow diminish, and we should see the output pressure increase up to a certain point. I'm not sure what that is. I think that's what you set on the side here. But once it reaches a certain point, the output flow will go to 0, and then we will, assuming there's no leaks, and then we'll test it for hydrogen. We should be able to test for hydrogen right now, actually, just on our output. So we're on high sensitivity mode, and so we've definitely got a working hydrogen generator. Alright, so we've got the leak detector, and the machine's actually stopped electrolyzing because it's reached its set point. We found a little leak on the dryer here. So when you put your hydrogen leak detector in the corner here, it would beep and make some noise. Only a very small leak, but enough to prevent it from reaching its set point. So with hydrogen, this is a passive detector, so with hydrogen it has to be above the fitting to detect a leak, because otherwise it's not going to detect it, it flows upwards. So I'll just show you what we saw just before. It was just this wasn't in enough. That's all it took. It's going to start electrolyzing again soon. If I tighten that one back up. It's just saturated, I think. But I'm happy to call that fixed. So, functioning. Done. I suppose that this is kind of a lesson in why you shouldn't trust Chinese hydrogen generators. I've shown you what's inside them. I've shown you what I've changed. I've had this thing apart a few times already, and I've shown you its propensity for leaks from places you wouldn't expect, and the caliber of some of the fittings that they use. So I guess if you ever find yourself rebuilding one of these, just keep all of that in mind, and go from there. I have read that a healthy functioning cell should be about 2.2, 2.3 volts. So if you're reading as much as 5 volts when it's operating, I think it's a dead cell. I think that's an instant cell replacement. So keep that in mind. I'll vent this and we should get an electrolysis start again. There we go. Just like that. Cool stuff. Done. Tell me what you're doing, Katie.
Finish off a piece of $10,000 toy.
No, it doesn't cost that much.
I don't know. I don't even care. I just do the easiest part that I can, because somebody cannot do that. They can only do the complicated thing. They don't even know how to close a pizza box.